Hello friends, this video on coordination compound part 8 is brought to you by examfear.com. No more fear from exam. So let's write the name of this compound. CONS2, CS2, CS2, NS2, 3, 2, SO4, 3. So the first step is find out cation and anion. So you know SO4 is sulfate, it's a negative charge. This is minus 2 into 3 is minus 6. This will be plus 6 by default. This is my anion, a negative ion. And this is cation, positive ion. So this will be given first priority and this will be given second priority. So let's write the name of this. So in this case, again in the complex, the first priority is given to ligands and then central atom. So let's write the ligand. Fortunately, there is only one ligand here, that is ethane 1,2-diamine. Ethane 1,2-diamine. This is the only ligand here. Right, since it's a little complex ligand, so I'll write in the bracket. Now there are 3 of these, so I'll write tri here. This is neutral, so I'm done with the ligands. The next is the central atom. Central atom is cobalt here. What is the oxidation state of cobalt? So plus 6 was for 2 of these box, right? So one box will be plus 3. This is neutral 0. So cobalt will get the plus 3 oxidation state. You can find it out on your own. Cobalt is plus 3 oxidation state. So I'm done with the cation part. Anion part is sulfate. So I'll just write sulfate. Okay, let's take next. So here AgNS3 2 AgCN2. Right. So the Cn is minus charge here. You see, this is minus 2 charge and this is plus 1. So minus 2 and plus 1 is total is minus 1 charge. This is minus 1, it has to be plus 1 charge. So this is again plus 1, this is again plus 1, Ag is plus 1, the overall is plus 2, and this is 0, this is minus 1. This is the oxidation state of all the elements in this. So overall, if you see, this is plus, this is minus, this is my anion, a negative charge, this is cation. So cation is given more priority. First I'll write cation. So cation is again a complex here, AgNS3 2. So in complex, first I give priority to ligand and then central metal. So ligand is my ammonia. So we'll write amine. And there are 2 amine, like diamine. So I'm done with the ligand for this complex. Then silver. So silver, I write silver. Oxidation state of silver is 1. I'm done with the left part. Now I'll start with the right part. Right part also has a complex. So we have this Cn minus, that is cyano. How many Cn minus? 2. Dicyano. I'm done with the ligand again. Next is metal. The metal is silver. Oxidation state of metal is plus 1. That's all. Now, I told you that if my metal is part of this negative ion, then instead of metal I use 8. So I can't use silver 8, so I'll use argentate. Like instead of silver I can use argentum also. Diamine argentum or silver 1 charge, dicyano argentate with 1 charge. Please note, this was the rule that if it is a negative, if the complex is negative here, okay, then I'll use 8 word with the metal. So if you see the rule, if it's a complex anion, the suffix 8 is used. Okay, complex cation, if it is a cation, then ion is used. But again, we had seen example where chlorine or sulfate was attached, so it was almost neutral, so nothing was used. But if it is complex anion, then this 8 term is suffixed. Let's take one more example. PTNH32ClNO2. This is a neutral molecule, and there is no cation anion here. It's a neutral molecule, right? So we'll write the name first. There is no cation anion. So here we have these ligands: ammonia, chlorine, nitro, 3 ligands. And as I know, for a complex, first I have to write ligands and then metal, right? So now we have 3 ligands here. One is ammonia, that is amine, Cl, that is chloro, and NO2, that is nitro. So let's arrange alphabetically. This is A, then B, C, and then N. This is alphabetically arranged. Okay, so first we'll write amine. How many amine? 2. Diamine. Then chloro. How many chloro? 1. Nothing is required. Then nitro. How many nitro? Only 1. Nothing is required. No suffix is required. So this is my ligands. And then I'll write metal. Metal is what? Platinum. So the charge is neutral on this complex, so we'll not use platinate or something. And then we'll write the oxidation number of platinum. So the oxidation of platinum will be NO2 is -1, Cl is -1, this is 0, it will be +2. This will be the name of this compound. Pretty easy. Next we'll write the name of this compound. Here again we'll write the cations and anions. You know this K3 is cation, this is cation, positive charge, and this whole thing is a negative charge. This is -3 charge, this is +3 charge. This is cation and this part is anion. So as per the logic, cation names comes first. Okay, so what is cation here? Cation is potassium. So we'll write this, right? Potassium. We're done with cation. Anion is a complex. So in this complex again, first is ligand and then metal. So what is the ligand here? C2O4, that is oxalato. Oxalato. How many oxalato? 3. So like trioxalato. Done with ligands. Then I have chromium. So I'll write, but again if you see, as I told that since it's an anion now, so instead of writing chromium, I'll write chromate. Only in case of negative charge. Since there is a negative charge here, so I'll write chromate here. Okay, so chromate. And what is the charge of this chromium? Chromium will have charge of +3. This is neutral. So this is -6 and +3, +3. It's all balanced now. Okay, so you can find the oxidation number. So we will have +3 charge. That will be the name of this compound. Okay. The next is COCl2, En2 and Cl. Again find cation and anion. This is anion and this is cation. This is cation, this is anion and negative charge. First we'll write for cation. In cation we have again a complex, so we'll write for ligand and then we'll write for metal. In ligand also we have chlorine, that is chloro, and En2, that is what? Ethane diamine. Ethane 1,2-diamine. So if you see the alphabetical order, C comes first and then E. So we'll write chloro first. How many chloro? 2. So write dichloro. This part is done. Then En2 is ethane 1,2-diamine. Since again it's a complex, I'll put in the braces. Now there are 2. Now as I told that for all these bidentate, tridentate ligand, instead of di, we use this word bis. Bi plus S, bis. This is something I have told you. So if you see here, instead of di, we will use bis, tri, tris, tetra, tetrakis for polydentate ligands. Okay. Okay. So we'll use this word bis. So I am done with the ligand part. Then metal. Metal is CO. CO is what? Cobalt. What is the charge in cobalt? So if we find the charge in cobalt is +3. Because this chlorine will get -2 charge. This will be 0 charge. This will be -1. So overall it will be +3 charge. So I'll write +3. So I am done with the cation part. Anion part is chlorine. So I'll write chloride here. Simple. Let's take the next one. That is CONS35 CO3Cl again. This is anion. This is cation. This is cation. This is anion. So cation is first, anion is second. In cation we have the complex. So complex will have ligand first and then we have metal. In ligand we have this NS3, that is amine, and CO3, that is carbonato. Okay. A and C. A comes first, so amine comes first. So amine, we write the name of ligand first. There are 5 amine, so it will be pentamine, and then carbonato, 1 carbonato, so it will be normal carbonato. Done with my ligands, then cobalt. Oxidation state of cobalt, if you found, this is 0 and this is -2, this is -1, it will be +3. You can actually find that. Cobalt, and then done with my cation. Anion is my chloride. Well, let's put chloride. This is the name, pentamine carbonato cobalt 3 chloride. Okay. Let's see the next one. HgCOSN4. So in this case, typically if you see this is the first part, it will be cation. It's a guess for us, but we'll double check on this. So Hg generally has plus charge, so +1 charge, and then this will be have -1 charge. So SCN has -1 charge, so -1 into 4 is -4 charge. So the cobalt will get -4, -5, and this is plus. So Hg will have +2 charge. Sorry, this charge you don't write. This is +3. +3 +1 +4 -4. So total Hg has +1 charge and this has -1 charge. If you want to calculate, that way also you'll find the cobalt oxidation state is +3. Okay, you can take cobalt as X, then SCN 4 SCN 4 into -1 is equal to net charge came out to be -1. You solve, X will come out to be +3. Okay, so let's solve this. This is my cation, this is first, and this is anion, this is second. So Hg is what? Mercury. So write this word mercury. Done. Now this anion has complex. So first we'll write ligands, and then we'll write metal. Ligand is what? SCN. SCN is what? Thiocyanato. And how many? 4 tetra. I'm done with the ligands. And cobalt. Now cobalt, please note that since the whole thing is a negative charge, right? It's an anion complex, so write cobaltate. And the charge here is 3. So one thing you have to note is the charge is negative here, then the metal ion name became cobaltate or nickelate. Okay. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.